Okay, so let's start. So, welcome. Thank you very much for being here. I'm really glad to be here in front of you. Really excited. So I hope it's going to be interesting. We're going to talk about OpenLayers, obviously, what's been happening since last Post4G, and what is going to happen in the future. Right, so first things first, I'm Olivia, work for Camp to Camp. I've been involved in the OpenLayers community for around 3 years, I would say more or less. Yeah, and you can reach me out like that. Right, so how it's going to work is first I'm going to do a quick introduction. So I'm assuming that most people here know what is OpenLayers and what it's about, generally. So I'm not going to spend too much time on it, and then give you a general status of the project. And again, not too much time. Yeah, okay. Sorry. Then we're going to talk about the new features that happened in the last year. Then we're going to see what's happening currently and what's going to happen soon in the project and what current projects we have for the future. And then I wanted to say a few words to encourage people to contribute to the library. All open source projects have the same concern. We need new contributors, and I'm just going to try and give some words about that. Right, so quick introduction to OpenLayers, openlayers.org. It's a web mapping library in JavaScript. You can find on the website, you can find a getting started guide and a lot of examples. So examples are great if you are lost and you want to know what the library is able to do. Current version is 7.4.0, so it follows semantic versioning. So if you stay on the same major version, nothing will break in your application. And upgrades between major versions are usually quite painless, and you just have to follow the upgrade guides. The source code is on GitHub. Issue tracker is also on GitHub, and the license is a BSD 2-clause license. So I just want to use the fact that all the audience is here, and I'm very curious. I want to know, I want to ask you a couple of questions. Is there anyone here that used OpenLayers and had a moment where they were like struggling with it, and the library didn't work as they thought it would, and they were like maybe cursing once or twice to it? Can you please raise your hand if you lived something like that? Okay, that's almost no one. Great. Awesome. Sorry for you guys. And on the other hand, anyone had like the opposite, very good moment, like, wow, it works great, better than expected maybe? Can you raise your hands? Wow. Okay, that's great. More than I thought. Great. Right, so thank you. The library is available on NPM, so you can just install the OL package, and then you can use it. It's a very quick example. There's also something very useful, which is called create OL app, and you can just run these 3 commands, and this will give you a running application with a full screen map in a few seconds. It really works, so if you don't want to go through all the trouble of creating it yourself, that's pretty useful. So the library has 334 contributors registered on GitHub. It has a constant, pretty strong activity. There's many sponsors. I've shown a few here, but there's more on Open Collective. So I want to thank all the sponsors, obviously, because it's really helping the library a lot. And how is the library doing? Yeah, so for my perspective, we see regularly new contributors, people trying to bring new things to the library, so that's great. There's not that many bug reports anymore, so it's pretty stable. It's up to date. It has a lot of quality assurance. And you can see here there's not that many issues and pull requests. I've seen much worse, so yeah, for me, it's doing really great. Right, so new features. There was a new styling property for text. Now you can specify a repeat interval alongside lines for text. You can specify an interval in pixels, and then you will see the labels repeating here. This was done actually in relation to OL Mapbox style, which is a library, kind of a sister library that parses Mapbox style objects and really create an OpenLayers map out of it. And so this is an ongoing effort to be more and more compliant with the Mapbox style specification. You also have now an easier way to load local or national projections using epsg.io. So previously, if you wanted to use local projections, you had to register them yourself and give the projection definition yourself, or do a query on a service like that. And now there's an API for that. You can just use from epsg code, and then it will query the service, and then it will just create the projection for you. So it's very handy if you use local projections. That should make your life easier. There was an example that was added that relies on PM ties. So PM ties, you may have heard of it. It's a container format for tied data. It's made mainly by Brandon Liu, which I think is not here, but yeah, thanks Brandon, it's great. So the PM ties project is hosted on GitHub, and basically the example is just registering a custom data loader that uses the PM ties system and then produces data ties, and then the rest is just the common OpenLayers stuff. You use the data type and render it, for example, for elevation data. So it shows that just with a custom loader, you can actually integrate with many different kind of formats. And there's an OL PM ties package actually on NPM, which should make your life even easier. Right, there's been a bit of work on detecting when the map is resized. So it's actually something that may be a big deal if you use OpenLayers and you had some kind of dynamic layout on your web page, and then the map would be changing its size, and then before that you would have to call a method to notify the library that the map was changing. You would have to do it yourself, and that would be very cumbersome. And now basically we rely on the resize observer API, so everything is automatic. You don't have to worry about it anymore. So yeah, very useful, better performance as well. There were a few improvements to the GeoTIFF source. You have now, there's a better handling of GeoTIFF files without tied layout. So if the data is arranged into rows, now there will be better network performance and better memory performance. There was also an issue with that was fixed with the resolutions computation from GeoTIFF. And also, the logic for reading the projection out of a GeoTIFF was made extensible. So if you use a GeoTIFF and you have a projection that's not EPSG something, then you can actually write your own logic for reading the projection, which is also kind of a big deal. Right, so the OGC API ties specification is now final. So the corresponding source in OpenLayers is now considered stable. Basically, it was just removing the experimental tag, and but it means also that now this source is part of the API, it's considered stable, and you can use it safely. There was also a big performance improvement in the case where you use many image layers, like 15 or more. So typically WMS layers. You can see here the image is taken from the map that was used to reproduce the issue, and you have a lot of WMS layers on top of each other. And in this kind of case, you would have a big performance drop in many devices, especially mobile devices. So this has been fixed, and now it works much better. So if you are in this situation, it would be a big difference for you as well. Yeah, and so we worked also on the WebGL, and I can tell you a lot about it because I was part of it. There was a WebGL vector tile renderer that was introduced in the library. It's still experimental. It's not, it doesn't work. I mean, it works, but it can probably be improved. It's using the same system as the WebGL vector renderer, so the same rendering system. The two renderers, vector and vector ties, now have a unified API, which makes more sense. Basically, you can either give them a style object with expressions for data-driven styling, or you can give them custom shaders as well, which is like lower level. You can also give them several styles. So if you give a renderer several styles, it means that the same data will be rendered with several passes and several symbologies. And this is really important if you want to have complex rendering. We added a few operators for expressions in square root, geometry type. These are taken from the Mapbox style specification. We try to be compliant to the latest version of the Mapbox style spec, and we'll talk about that a bit later as well. And the heat detection was completely reworked to be much more efficient. It was so currently it only works for the points, still only works for the points, but we can probably make it work for lines and polygons very soon, right? Yeah, it's much more performant as well. Right, so that's it for the new features. What we are expecting for the near future, a lot of interesting stuff. So I'm going to say a few words about that. It's maybe a bit too technical, but it's something that's been discussed for a while in the community, and we want to have a more efficient internal storage system for data. To give you a general idea, if you load a data set that has like 10,000 rows, then currently the library will create 10,000 objects, feature objects, and will store them in memory on the main thread. All this is very slow, it's not very efficient, and what we want to do, we have something that's where a worker would load all the data and store it, and then the main thread will kind of use a server client architecture and query only the data that it needs. For example, if you click on the map or if you do something like that. So less blocking of the main thread, less memory footprint, and that could be a performance improvement for a lot of places in the library. But it's still kind of far away, I would say. There's more WebGL stuff coming. So I have to mention first that all the recent work on WebGL and the work to come is funded by the city of Hamburg. So the city of Hamburg was really expressed a very strong interest in having OpenLayers being able to render Mapbox-style objects as close as possible to the reference implementation, which would be MapLibre. So they have been funding work to get OpenLayers closer and closer to the MapLibre rendering, basically. So what we're currently working on is having more symbols. So you can see here there are circles, but there are also regular shapes, stars, and things like that, with outlines, which was not possible before. We're going to do line joins, dashes, offsets, symbols along lines, pattern and image fields. This is all needed to be able to render a Mapbox style correctly. There's also better performance that we want to obtain with different things, like maybe doing more things in the workers. Again, workers are really essential for performance. And also filtering geometries earlier in the whole process so that we don't have that much work on the GPU, on the graphical chip. And also we want to be able to render text, because the WebGL renderers in OpenLayers have never been able so far to render text. And we want to have that eventually. Right, so you can see here a comparison. To do this comparison, I used a very simple Mapbox style, actually. It's provided by Hamburg. It's kind of like cadastre data, sort of. And I took a place where it was really favorable, I have to say. But you can see here on the left is the current version of the OpenLayers WebGL renderers, and on the right is MapLibre. And in terms of visual quality, we're getting really close. Performance is not that great with OpenLayers. Like I said, there's still a lot of work on that part. But in terms of the rendering, I think we're getting really close. And also I have to mention that on the left, we are really parsing the Mapbox style that we get, the original Mapbox style, and we process it a little bit, basically to make it match with the OpenLayers styling format, and then we render it. So I mean, we're getting really close to this final target, and I'm really proud of it personally, and I have big hopes for it for the future. I think it's going to be great. Right, so we talked a little bit about expressions in styles. Expressions currently are used for vector styling and for raster, WebGL raster rendering. And now people have been thinking, well, you know, expressions are really useful for everything data-driven. We could use them more in the library. for example, for the canvas renderers, the main renderers, currently you can use like style functions. You would write a function in JavaScript and do kind of logic for whatever styling you want. But if we move that to using expressions, then it would give a much more strict system. It doesn't mean you cannot do as much. It just means you have less ways to do it. And also the expressions are also serializable. So it means whatever you define with expressions, you can also give it to a worker, and the worker will do all the work, will render everything, and just give you back the images, for example. And that unlocks a lot of possibilities for better performance. So there was a draft pull request that was open to kind of kickstart all this movement for expression-based styling. There's also the possibility to use expressions for pre-processing data for data types. The heat map parameters currently are also callbacks. They could be expressions. And we could also do discrete data interpolation. And yeah, you see on the right, this is what a style with expressions look like. It's a very simple style, but yeah, that's what it would look like. So yeah, discrete data interpolation. This is because this was a very interesting also experiment. This is a draft pull request, and you can see here it was made by Team Sharp as well. We are loading weather data, and weather data is usually based on a grid, and it's discrete data on a grid. And so we do interpolation between all these points to have a field, a uniform field across the whole surface. And then we can actually simulate the movement of particles in that field. And that's very promising. We also want to use the power of expressions to let people decide, what are the colors of the particles, what are their size, their lifetime, something like that. So all this could be expressed in a data-driven way as well. So that's very promising as well. Right, so just a few words now if you feel like you're very interested in the library and you want to help, you want to contribute, and maybe you don't know where to start, it's maybe a bit frightening. Just a few pieces of advice. Either you bring up a bug and then you're welcome to fix it, or a feature request. But there are also issues that are tagged with the pull request accepted tag, and then you can just pick one and say, I'll try my hand on this. Usually we put this on features that doesn't look too hard. You should also start small, obviously. So try and focus on one specific part. Typically, like the data parsers are a good way to get your hand inside the library. The map controls would be another example of things that are not touching too much. Read the contribution guidelines, and then, yeah, you have to test everything. And I just want to emphasize a little bit on that, because if you are, motivated to do a contribution, just an occasional contribution, if your contribution is really well tested, it means that you can there's no strings attached. You can just go away and never come back anymore. And then people will not have to, ping you and ask you, how did that work? I don't understand. Because when you test it, you say, okay, this is how it's supposed to work. This is what it's supposed to do. And then, yeah, that's it. It's merged, and you're safe. You won't be harassed by people several years afterward, and I think it's reassuring. Yeah, and you can ask for help on GitHub, of course, if you need help. So yeah, if you want to contribute, please feel free. We will help you, and that would be great. And yeah, I'm done. That's finished. Thank you very much.